Let's try and do this limit problem. So the normal routine is for us to put the 2 into the x, and it turns out to be 0 over 0. When it comes to limits, when you get 0 over 0, you can't determine anything. Sometimes the limit exists, sometimes it doesn't exist. You just don't know. You need to do something cunning in order to find the limit. In this case, we need to factorize in order to find the limit. So you would factorize the numerator. It turns out to be two numbers multiplied together to give you 10. You have to be able to create a 3. It turns out to be x minus 2 and then x plus 5. X plus 5. And then down here is it stays the same. And as x approaches 0. And it turns out that these two, they cancel each other out to give you lim of x plus 5, x tends to 0. Now you can put 0 into here. Nothing breaks down. You're not dividing by 0. Nothing breaks down. It turns out to be 5. So what that means is this here looks like this. Remember, dead on 0, it breaks down. That's why there's a hole in the middle. But if imagine one person here, one person here, you're walking towards 2 from the left-hand side. From the right-hand side, it turns out that you will reach a height of 5. And I need to justify why you're able to just cancel these two out. So remember from a long time ago, I've already explained why this thing here, lim x over x, as x tends to 0, the graph looks like this. Dead on 0, it breaks down. You're not allowed to divide by 0. So I've shown this before. So here, imagine person on the left, person on the right. As you head towards 0, it will reach a limit of 1. Now let's look at this limit of x squared over x. This thing here looks like this. You can think of this as being like x times x over x. These two cancel each other out, so it acts like like y equals x. So it acts like this. It acts like this. But just remember, because of this, dead on 0, it breaks down. So there's a hole in the middle here. Now here, the limit is still 0. The important thing is that these two, they cancel each other out, just like this thing here cancels each other out. If you consider this, hang on. If you consider this, lim x to the power 3 over x. Take the limit as x tends to 0. It will look something like this. This thing here acts like, this thing here acts like x squared. So it looks like this. Everywhere else apart from 0, it acts like y equals x squared. But dead on 0, it breaks down because you're not allowed to divide by 0. So so this graph here actually looks like this. And the limit here still exists. It is 0. The point is that if you look at this, if you look at this, these two cancel each other out, just like this thing here. That's why you're able to just cancel these two out when it comes to limits. Okay.